Okay, so this is 3.1, and this section is called derivative. Yeah, so a couple of lectures ago, before, we're calculating the slope of a tangent line. So let me draw it again. The function was x squared, so f of x equals x squared. And we had a parabola. Okay, and we're given a point. I think it was 2, 4. So let's just put it here. I know it doesn't look like 4, but it is 4. Okay, so this is 4, this is 2. And yeah, let me write those coordinates, 2, 4. And then we had, and the way we were doing it is we pick some random, arbitrary point Q with coordinates, right, x and y, but y in our case is just x squared, right? So this is x, right, and y, or we could call it x f of a. Let me write it here. So x, or maybe with different color. We don't need this xy. And yeah, so this was x, right? And this is f of x. And that's where this x squared came from. And then, yeah, we calculated the slope, right? We were plugging in numbers that were closer and closer. Let me write that. Right, so slope will be, right, so we'll take, and we're taking this. It's in a sense, right, we could call it y sub 2 minus y sub 1. Right, so we'll have x squared minus 4. And the bottom is, right, x2, x sub 2 minus x sub 1. Right? It's just formula for slope. So this is going to be x minus 2. Okay, so we had this formula for slope, and we're basically plugging in numbers that were closer and closer to 2, right? So we're taking this point and moving it down, or moving those x's closer to that 2. And we can do it from both sides, and we did. Right? And also, we looked at it from a kind of different angle. So that slope was a limit, right? So we wrote that whole idea, this whole concept, as a limit with x is approaching 2. And then we had x squared minus 4 and x minus 2. And then you guys already know how to calculate this limit. We can't directly plug in that 2 yet, but what we can do, we can simplify this x squared minus 4. So I will get limit with x approaching 2. Now I have this, yeah, we've already done it. Let me just write x plus 2. And so at this point we can plug in that 2 in for x, and we get 4. Okay, yeah, and basically, right, initially, right, that tangent line is not really a tangent line. It's just it's a secant line, but right, as we're bringing that q closer and closer to my point 2, 4, right, eventually if we calculate the limit, right, we actually get a slope of the tangent line, right? So we get a slope of the tangent line, right, which would be this line at that particular point, right? So that was 4. Anyway, let me erase this. This is just ugly. Okay. Yeah, so we'll basically do something similar right now. We'll just change those the notation a little bit, right, of this. And yeah, let me make another graph. So yeah, and we'll do a couple different ways to look at it. Look at the derivative. Anyway, so again, right, we have some, it doesn't have to be we have some abstract curve, could also be parabola. And yeah, so I'll have let me take a different color. Yeah, so I'll have 2 points, same idea. This one with coordinates c and f of c. Okay. Yeah, so we're just simply making it more abstract and more general. And this point, this will be x, coordinates f, x and f of x. All right, so, and we'll write again a formula for slope, right, using this new notation. I hope it's not gonna go anywhere. Okay. Okay, I don't know. Obviously, I'm struggling. Anyway, right, so we'll write m. And again, we'll have a limit. And because again, right, we'll be moving this this point x towards point C, so we'll have x approaches C. And then we'll take f of x minus f of c. And then the bottom will be x minus c. Okay, so that's one way of looking at it, and here is another one, another way, another different perspective. Okay, so again we start with the graph. And we have another curve. Let me make it better. Okay, so a curve. And again, we have 2 points. This point, we could, yeah, let's write it as x, f of x. And then we'll have another point. And this one, yeah, let's think about that second point. So I'll have x here. Now, right, so coordinate of x coordinate of the blue point. Let me make it blue actually. Everything blue related to that point. Okay, yeah, so this coordinate is right there. And now the crucial thing is that, right, the distance between x coordinate of the white point and the x coordinate of that blue point, that's going to be h, right? So we're going to mark it, denote it as h. Well, if this is h, then x coordinate of this one is going to be x plus h. Okay, now the y coordinate of that original point is obviously f of x. But now the blue coordinate, or the y coordinate of the blue point, is going to be, right, f of x plus h. Okay, so we can write the coordinates of this point. So that's going to be x plus h is the x coordinate, and then f of x plus h. Okay, so now if we want to calculate slope right now at this point, and I would take a limit again, because again, right, we'll take this blue point and start moving it towards the white point, right? So the value of h is going to be getting smaller and smaller, and well, basically it's going to approach 0. Okay, so this is h approaching 0. And so you see what the difference is, right? So in this, let me actually finish it. Right, so we'll have, what do we have? And again, right, I'll take this minus that, right, and then this minus that in the bottom. Right, so again, still the same idea, rise over run. And yeah, let me make it blue actually, so that you guys know what everything comes from. So x plus h. Now I'm just subtracting f of x. Okay, and then the bottom is x plus h. So x coordinate of the blue point minus x. So you see that, right, these two will cancel out. The x is at the denominator. So it's going to be limit with h approaching 0. And then we'll have f of x plus h minus f of x divided by h. Okay. Yeah, so that basically is the definition of derivative. But yeah, I'm going to write it maybe more a slightly different way. Let's do an example. Let's just do something maybe a little bit silly. Silly because, well, anyway. So find the slope of the graph yeah, so the equation, the function is 2x minus 3, and we already know what the slope is, right? The slope is 2 because it's just a straight line. Anyway, I managed. So it's right at the point 2,1. Okay, so we'll try to use both of those definitions, right? The one with c and the other one with h, and see what we get. Yeah, so we have the x coordinate, right? So we're going to call this, right? I'll use that first definition with c first, right? So c will, in our case, will be 2, right? And f of c is 1. All right, so let's see. Let's plug everything in and see what happens. Okay, so we had, let me write that formula, that definition. So it went something like this: limit, and I'm talking about, let me show it to you. Right? I'm talking about this one. Okay. So that's limit with x approaching c. I'm just writing the formula first. And then we have f of x minus f of c and divided by x minus c. Okay. yeah, so let's plug in what we know. So f of x, that there should be that limit, right? The limit should be there. I just didn't write it. So 2x minus 3 is my f of x. So 2x minus 3. And then minus f of c is 1. Okay, at the bottom I have x minus 2. All right. So maybe now I'll write that limit. So limit with x approaching, well, I should have written that limit over there too, and because now the c is 2, right? So I have 2x minus 3, so it's going to be 2x minus 4. The bottom is x minus 2. And yeah, just a little, we need to do a little bit of algebra, right? So we have limit with x approaching 2, factoring 2 out, x minus 2 divided by x minus 2. So that factor cancels out, and we get 2. Okay, so the slope is 2, which we already knew. Okay, so let's use that other formula we had, and it went something like this. So that was f of x plus h. I forgot the limit. So there's a limit with h approaching 0, and then we have f of x plus h minus f of x, and the bottom was just h, right? Because those x's cancelled out. Okay, so let's plug everything in, and maybe let's start with, right? So let's start with making. Let's make it green, and this one, let's make it red. I'm not doing a good job writing this. Alright, so this is just f of x. Alright, so before, right, I plug everything in, let me just write what that f of x and f of x plus h is, right? So let's start with f of x. So f of x, what was that? 2x minus 3, right? I think so. 2x minus 3. And now I'm doing f of x plus h. Right, so I hope you see what I'm doing, right? What I'm doing is just separating those, right? So I'm trying to figure out what this is and what this is, and if after I'm done, right, I will take these two and I will plug it into our formula, or plug them into the formula. Okay, so let's finish that f of x plus h. Okay, so the only thing I'm doing here, I'm taking this x plus h, right, this, and I'm plugging it into the, right, into my function, into the formula. Right, so let's do that. So I have 2, right, and then I have that x plus h, and then minus 3. Okay, so eventually it's going to be 2x plus 2h minus 3. Okay, so this is f of x plus h. Right, so now I'm going to take both of them. Right, I'm going to take the red one and put it right there. And then I'm going to take the green one and put it right there. Or first, I guess the green one. Okay, so that equals, now we have limit with h approaching 0. And now we have that, the green part. So 2x plus 2h plus 2h minus 3. And now we have the red part. So then it's minus the extended fraction line. Now I'm putting the red expression. So 2x the function, right? F of x. So 2x minus 3. So you see that I'm using parentheses, right? Because what I'll have to do, I'll have to distribute that minus, right, to both of those terms. So parentheses just kind of tell me that I need to do that, right? If I don't have the parentheses, then I don't know, it just looks like negative 2x and negative 3, but it's going to be different. Okay, so we have limit h approaching 0. Yeah, let's still use those colors. Right, so 2x plus 2h minus 3. Right, and then we have minus 2x plus 3 over h. I'm struggling again. I don't know. Oh, here we go. Maybe I need to move it faster. Anyway, I think I can fit it here. So limit with h approaching 0. And let's cancel what we can cancel. So these two are gone. Negative 3, positive 3. So the fraction line is too long. Right, so we have made it too long still. 2h over h. Cancel the h's and we get 2. Alright. So yeah, that was a little silly, right? Because we already knew what that slope is. But yeah, you'll see more examples, obviously. So yeah, let me officially write the definition of the derivative. So definition. So basically, yeah, let's just write. So instead of writing that slope, right? Because, well, because in a sense, right, it's not, if I just have a straight line and I'm calculating the derivative, I'm going to get a slope. But if my equation, if my function is not really a straight line, it's a curve, right, I'm going to get a formula for slope. Anyway, so this is one of the symbols for derivative. So it's f prime, right, of x. So derivative. So let's just write it. So I'm going to use that formula with h. That one I think is more useful. Okay, so we have limit. I mean, they're both useful for just different purposes. Anyway, so I have h approaching 0, and then we have this, right? So that was f of x plus h minus f of x, and the bottom is just h. Okay, so this is the definition of a derivative. And yeah, function, let's just write function is differentiable. So that means we can take a derivative exists. If that limit exists. Okay. Okay, so this is the definition of derivative. Okay. So first thing we'll do, I'll show you a couple different types of notation for derivative. So notation for derivative. Okay, so you've seen the first one, right? F prime of x. Then we have this one, dy dx, so derivative with respect to x. Then we can just write y prime. We could do derivative of a function f of x with respect to x. Right, so that with respect to x is this one, right? And then there's a notation, type of notation used in physics. So x with a dot above it. Okay, so that basically means derivative with respect to time. So dx dt. So derivative with respect to time. Sometimes you will see something like this also, like in higher level math courses. So it's d and then a bracket and y instead is inside those brackets. So derivative of y. Okay, so let me give you a couple examples. Of calculating derivatives. So this is, I think it's just example 1. So find derivative. This is a derivative of f of x equals x cubed. Okay, so yeah, using definition, right? So we have limit with h approaching 0, and then we have the definition, right? So it was f of x plus h minus f of x divided by h. Okay, so our function is, let me write that, those two separate expressions, right? So this one and this one. Okay, so let's start with that red one. So f of x, that was x cubed, right? We're finding derivative of x cubed. Okay, so now I need to do f of x plus h. So I need to take that x plus h and plug it into my original function. So that's gonna be, right, so I'm taking this x plus h and putting it right there. Okay, so parentheses, I have x plus h, and that's to the third power. Okay, so I need to multiply it all out, right? So that basically means x plus h times x plus h 3 times, right? Times another one. Okay, so we have, if I multiply these two, right, I'm getting x squared And then that's gonna be what is it gonna be? 2hx, and then h squared plus h squared. Okay, so I still need to multiply it by this one, x plus h. Okay, so we get, maybe I'll write it here. So I'm multiplying the first term, so x cubed. Now x squared times h plus h x squared. Now I'm taking this term, right? Well, this is pretty simple algebra. So I'm multiplying this by both, right? And then this by both. And then finally this by both, right? Anyway, let's finish it. So now I have 2 plus 2hx squared plus 2h squared x plus h squared x plus h cubed. Okay, so that's the whole thing, is that f of x plus h. All right, so let's plug them in. So I have limit with h approaching 0, and then we have, I'm just looking at it whether I can combine something. Let me just double check it. Yeah, maybe we can combine something, but let's not. Let's just copy it. So I'll have x cubed plus, I think we can combine, well, anyway, we don't need to do that. H x squared, right, plus 2h x squared plus 2h squared x plus, do I have more space? Yeah, I do. Okay. Plus h squared x plus h cubed. And then I have minus, right? So now I'm here. And I finished that f of x plus h, so now I'm subtracting f of x. So minus x cubed. Okay. And it's all divided by h. All right, so this is a pretty important step, right? So I canceled this and that. Now you see that each term has h, right? So I can cancel also that h, right? I could factor it out technically and then cancel it, but we can do it without that. So that's going to disappear, right? So from each term I'm going to kind of cancel one of those h's, right? So here, then this will just become h, this also, right, just h, and this will become square, h square. Okay, so let's write down what we have. So limit with h approaching 0. So what do we have left? We have this part, and we could even combine these. So I'm getting 3x squared okay, then I have this term, right? Then I'm going to write this term, and then at the end I'm going to write that one. Okay, so 3x squared plus 2hx plus hx plus h squared. Okay, so at this point, what I can do, I can take that 0 and plug it in for h, right? So here, here, and here. Okay. So we get that's a limit h approaching 0, and well, after I plug the 0 into all those h's, right, I only end up with 3x squared, and this is just 3x squared. Okay, so that's the derivative of x cubed. Okay, so you guys saw that with that previous example, right? We calculated that was, let me write it here on the side. Let me see what that was. So that was 2x minus 3, right? So that previous example was f of x, 2x minus 3. And we got the derivative, right? So f prime of x was 2. Right, so you see that what happens here, this is a straight line, so the slope is just 2, right? And this is what we found, right? F prime of x, so that slope is 2. But here, this is not a straight line, right? We have x cubed is a curve. So in our case, in this case, right, we didn't get one particular number, right, specific number. We got a formula, right, with a variable in it. So now to calculate the slope at different points on the curve, right, we will just be plugging those x's in for x in the formula, in that derivative. Okay, so let me just write it maybe in a different way. So derivative with respect to x of x cubed equals 3x squared. All right, so now, yeah, let's calculate a couple of those slopes. So what is the slope? Let's do it on the second page, on a new page. All right, so we have let me sketch that graph. So cubic function would be something like this. Okay, so this is f of x equals x cubed. Okay, so now the question is, what is the slope at this point? Right? So this is 1 here. 1, 1. Right, so we have a formula for slope. So let me write it. So what is the slope? Well, it's a tangent line, right, to the graph at that point. What is the slope of a tangent line? Of a tangent line, or of a line tangent to the curve at x equals 1. Okay, so let me draw the tangent line. All right, so it's going to be something like this. Okay, so that's the tangent line to the curve at that point. Okay, so let's just calculate it, right? So we have that formula for slope, which was f prime of x, 3x squared. Okay, so f prime of 1 is going to be 3 times 1 squared. Okay, so the slope is 3. and the slope of that line, m equals 3. Okay, so let's calculate maybe a different point, maybe at 2. So x is the different color. Alright, so at x equals 2. And so that point is going to be 2, 8. Okay, so let's put it on that line here. Okay, so 2, 8. So if this is 1, this is 2. Let's make it a little farther. Okay, 2, 8. And then we have the tangent line like this. Right, so let's see what that is going to be. Again, right, I'm taking the formula for slope, which is 3x squared. I'm doing f prime of 2. Okay, so we have 3 times 2 squared, so that's 12. Okay, so the slope of the red line is m equals 12. Right, so pretty steep line. Right, it doesn't look like that because the actual graph would be something like this. I'm not much steeper. Anyway, I didn't draw it like that because it create other problems. Anyway, yeah, so that's how we calculate slope of a tangent line to the curve at a particular point. And yeah, just kind of keep in mind that that derivative is basically a slope, right? It's associated, related to the idea of slope. And when you calculate derivative of a function, it either gives you a slope or formula for a slope. Okay.